Dot tender ke?
For the kenal lah buku ni. Number teori kan?
Kenal.
Saya tengok. Okay, Alhamdulillah masih ingat lagi. Okay, so today I will take over starting from today. Class Ergodic Theory 1. Okay. So for the starting from week 8 until the end lah. Okay. Before we start, can I check the attendance first? So we have 1, 2, 3, 4, 5, 6, 7, 8. Okay. Semua datang. Senang. Sikit je. Okay. So, sekejap. Saya dah record. Okay. Let us continue with new topic. Let me share my screen. Okay. Can you see?
Not yet. Gelap.
Not yet. Belum sampai lagi. Memang kosong pun. Oh, gelap. Okay. Saya tunggu dulu. Tunggu dia loading jap. Okay, sekejap. Okay. Cancel. Now I'm sharing my screen. Is it okay now?
Gelap juga.
Mana boleh gelap ni?
Okey dah. Dah nampak dah.
Nampak dah.
Dah.
Yang PDF
Alright.
annotator tu kan.
Annotator. Okay. Sekejap sementara tu saya tengah temuduga supervisor senior awak. Sekejap Okay. So for week 8, lecture number 8, class number 1. So we will continue with from the previous classes that Siti Fatimah already taught. So I think from for this semester, this lecture ni, you already know the definition of transformation, measure preserving transformation, how to find the measure, Bernoulli shift, Bernoulli measure, Becker's transformation, I think. Ada Becker's tak?
Ada.
Okay, ada Becker's, Dyadic, measurable space, apa tu? Infinite sequence, doubly infinite sequence, and so on. Okay, so I hope all of you already remember all those terms, because we are going to use that for the rest of semester lah. Okay, now for the new topic, we consider number 8. Consider on a segment X from 0 until 1, and we also each M is called the usual measure. Okay, So we will consider usually we will consider 4 examples. So the first examples is this: Tx is equals to 2x mod 1 . So from the previous class, this measure preserving transformation. Okay, measure preserving transformation. So this transformation is called dyadic transformation. Okay. Now the question, is it ergodic? Is it ergodic or not? Remember? Do you remember?
Ergodic.
Yes, it is ergodic. So now for the second example is Baker's, or we call it as CAT transformation. Okay. So usually we define it on the segment 0, 1 multiple with 0, 1 multiply with 0, 1 segment. So there are two dimensional. So that's why we have this. And B of xy, or we call it as Baker transformation, defined on the points x and y, is equals to 2x and half of y if the segment is between 0 and 1/2. And the second transformation is for the case of half less than x less than 1. So we have 2x minus 1 and half of y plus 1/2 if we have the transformation in this segment. Okay, next we move. Okay, so the example number 3 is the Bernoulli shift. So if we have this set 0, 1, 1, and the partition function of x is equals to, starting from 0 until infinity, of e of I, where e of I is equals to e for any I, where the measure of the Bernoulli is V0 is equals to V1 is equals to 1/2. So we define Bernoulli shift if omega taken from x such that we have omega is equals to omega 1, omega 2, omega 3. So this is the one-sided sequence, because if you can see this one, we have from to the right. So it is one-sided sequence. So this x actually, this one is not one-to-one correspondence. I will explain later. So this one we have what? T omega. We transformation. We apply the transformation on the omega, n is equals to this omega n plus 1. And for the example number 4, we have the example for the double-sided sequence. So we define y is equals to the partition function of this, not from 0 but from minus infinity to infinity, because it is double-sided. EI, where E of EI is equals to E. So we define the Bernoulli shift is the same. Which is this one. Okay. And it is 1-to-1. Correspondence. This one. This is not 1-to-1 correspondence. This is 1-to-1 correspondence. And defined by this. Omega is omega minus 2, omega minus 1, omega 0, omega 1, omega 2, and so on. Alright. Later for the previous, in the next lecture also, we will always use this for examples. So now, the new topic that we want to discover today is about isomorphism. So let's write here, isomorphism. First thing that you need to have is two transformations. So the first one, so let X sigma algebra 1 and is be the probability measure space.
Doktor,
Yep.
saya rasa sama ada internet saya je ke internet ataupun internet doktor.
Kenapa?
Skrinnya
Tak stable.
blur.
Gelap.
Screen freeze.
Sekejap
Okey dah
pakai
okey.
dekat ni, dekat office, memang ini kurang ni lah sikit. Saya try guna kabel. Kabel dah. Try pakai kabel ni jadi macam mana pula. Okay. Boleh nampak tak ni?
Boleh?
Okay.
Isomorphism kan?
Isomorphism. Okay, now isomorphism. So the first thing that you need to have is two transformations. So let's define these two transformations. The first transformation is defined by this one. Okay, so we let X F1 bukan F, apa tu, sigma algebra F1 sigma algebra 1 and mu1 be the probability measure space. Okay, now and we define T, the transformation is from X to X, that maps from X to X, is a measure preserving transformation. So we call this as arbitrary transformation. Can be anything. Okay, number 2. Let X sigma algebra 2 and mu 2 again be the same probability measure space, and we define the transformation S from Y to Y. Okay, this one also measure preserving transformation and arbitrary. So definition. The measure preserving transformations T on this space X F sigma algebra 1 and mu1 and S on. Ya, gelap lagi.
Yang bukan. Yang S tu, S dekat yang MPT kedua tu. Tu S transformation juga ke?
Yes, transformation. Transformation, bukan permutation apa, transformation, any transformation. P kan transformation, S to another term. Sebab saya kena ada nak different two transformation. Boleh? Saya denote the transformation as S.
Faham.
Okay. So the measure preserving transformation T on the first probability measure space and S on the second probability measure space, which is this one, Y, sigma algebra 2 and mu2, are called isomorphic if there exists 1-to-1 correspondence from, so we call this phi that map from X to Y such that, okay, we will have three properties. Boleh salin? So isomorphic. Boleh ada soalan?
Doktor last tulis yang definition sampai S on ni kan? Y1 F2 dengan
saya baru tulis kat definition dia tapi belum habis lagi, baru kat such that.
Freeze doktor. Doktor
Freeze.
Okey, nampak dah.
Ni tak suka guna internet UIA ni. Dia punya ni tak berapa ni. Tak kuat. Boleh lah. Tak apa, saya slow-slow Isomorphic meaning copy. Macam similar. So the first properties that you need to have is so I repeat So definition for the measure preserving transformation T on the first probability space and S on the second probability space are called isomorphic if there exists 1-to-1 correspondence from phi, which is from phi that met from X to Y such that, okay, the first properties is for any A, meaning for any set which is taken from the sigma algebra 1, we will have phi A. That means we apply the maps phi to A on the set A, which is the element in the second sigma algebra, and B or set B, which is taken from the second sigma algebra, we will have the inverse of this B is in the first sigma algebra. Algebra number 1. Okay. The first properties that we say that the two major preserving transformations are isomorphic if for any set taken from the first, kita akan dapat the image is in the second. So kalau kita ambil another set from the second, we will have the inverse is in the first. Itu maksud isomorphic. Okay, next properties, property number 2. For any set A taken from sigma algebra 1, we have the measure of mu1A. Sebab mu1 apa? Sebab mu1 kan sebab A taken from the F1, so that means kita kena guna measure 1 lah. So measure 1A is equals to measure of 2 of the image of A. Since this is 1-to-1 correspondence. Then, since this is a 1-to-1 correspondence, then automatically you will have for any B taken from F2, you have mu2B is equals to using this mu1, because this one taken from F1, mu1 of the pre-image of B. Yes, mu2B is equals to mu1 of pre-image of B. The second properties. Now, the third properties, we will draw a commutative diagram. So a commutative diagram is given by this. So we have two transformations, right? So this T is from X to X. And another transformation is S from Y to Y. So how to draw the commutative diagram? So you will have X, X, Y, and Y. Okay. So this X to X, we apply transformation T. This Y to Y, we apply transformation S. Okay. Now, there's so isomorphism meaning that there is a map, okay, that brings you from X to Y. So we call it as this map, which is phi from X to Y. So that means here we have phi. And here also we have phi. Is that okay? So we call this as commutative diagram. So how is the operations of this diagram? Alright, with red. Okay, operations. So is how can you go from this X to this Y? There are two ways of going from X to Y. So it's either you go from here and then this one, right? And another path that you can go is from this to this. Oops. Yes, another this one and this one. Is that okay? Okay, for the path that is from this side, say I choose another color, pink. So you will have for any x in x, you will have first from x, okay, to y here, from this one first. Okay, this is another the first path. So 1. So you will have what? How is the operation work? So you apply, you have x, all right? You taken x from this, and then you go to this path, all right? And then what transformation that you have applied? So t, right? So you will have t of x. And you apply phi, because you want to go from here. This is equals to the left, which is this one, and this one. Okay, either you go this way, you have to apply phi first, phi x, and then you apply s. Is that okay? This is path number 2. Okay, now, so we call this, so if the 3 properties are satisfied, so meaning that if you have transformation, 2 transformation, S and T, and then you have shown that these 2 transformations satisfy these 3 properties, then we call it S and T are isomorphic. Okay. Let's try to show by examples. So example number 1. Okay, now we will show for dyadic transformation. Okay, so let's refer to the first example, which is the dyadic transformation. Again, you have x is given by this 0 and 1, okay, and then f1 is the sigma algebra, or we call it as B. I denote this as B, which is Borel sigma algebra on X, and we define M as the usual Lebesgue measure. And the dyadic transformation is given by this formula, which is 2x is equals to 2x, tx is equals to 2x mod 1. So the second transformation I will show for Bernoulli. So for Bernoulli, you will have this partition function. Why? Because you need to have two probability measure space, right? So x is for dyadic, y is for Bernoulli. So this is equals to y equals to from 0 to infinity of ei, and ei is taken the value of 0 and 1 only. So the measure of this is 1/2, and the measure of 1 is 1/2. So if you have a omega taken from this y, you will have the shift, Bernoulli shift of SWN is equals to omega n plus 1. We apply the transformation. So in previous example, I use T kan? But here I cannot use the same T because I use T already in this transformation. So I need to use another a symbol. So I use S. So mu here is called Bernoulli measure. Okay. Now you have two different transformations, which is dyadic and also Bernoulli. So in dyadic, you have to use all the properties that is available for dyadic, which is X is from segment 0, 1. Dyadic punya formula dengan M, which is the measure. So by patron you have V0 tu, and then mu. It's called the Bernoulli measure, and also the transformation, which is this one. Okay, now let us show that T here and S here is isomorphic. So let us show S and T are iso. Okay, T dengan S. Saya show T dulu baru S. Okay, now. Okay, so dyadic you know already. What about Bernoulli measure? So let's try to show a list down. Let's try to write all the necessary information about Bernoulli measure. So Bernoulli measure is, let's say I have this A. It's a set of omega taken from Y, Xn, the cylinder set, Xn1 omega is equals to I1 until Xn k omega is equals to Ik. Okay, we call this as the cylinder set. Cylinder set. Okay, now you want to find the measure of A. So in Bernoulli we use mu instead of M. Okay, measure of A is equals to mu of this, the whole ni lah semua. This one. The whole set is equals to I1 until Xn k omega equals to Ik. Is that okay, this part? You can, kalau tak clear, you can put or you can write something on the chat.
Clear, Doctor.
Alright, thank you. Alright, go. So, now what is the Bernoulli measure for this? So we have V I1 multiply with V I2 until multiply with V Ik. Okay, now now for the case of this one, X is dyadic kan? X is for dyadic transformation. So you have a 0 segment from 0, 1 segment, and then you have for any X, you can define the coordinates. Function is 0 point, X1, X2, X3, and so on. So we call this as dyadic fraction. So in this dyadic fraction, we only use 2 digits. Allah, kenapa tulisan macam ni? Salah. Okay, we only use 2 digits which are 0 or 1. Or either you can have x1 equals to 0 or x1 equals to 1. Okay, now. So again, for the kalau Bernoulli measure, you will have y in the partition function from 0 until infinity. So I have EI, where EI is from 0 or 1. So the omega taken from this y is actually omega is equal to this sequence. So omega 0, omega 1, omega 2, and so on. So here in this case, omega 0, omega I, either 0 or 1. Okay. Okay, so now you have these two information for each transformations. So let us try to define. Okay, now we want to let's look back the definition of the isomorphism. So from the definition of isomorphism, if there exists one-to-one correspondence, so that means the first step that we need to do is we need to show there are one-to-one correspondence between these two transformations that you have. Okay, now I can define the correspondence by the following way. Okay, the first one, phi x to y, because the one-to-one correspondence is from the map from x to y. That means for any x, I have 0.x1, 0.x1, x2, until so on. So the image of this x will be I can write, because the image is the image of this. We just cancel the first, right? Sebab Indiadik 2x mod 1. So actually kalau ini darab dengan 2, it's like x2, x1, x1, x2, x3, and so on. This is the image of x. So actually, okay. So instead of this form, okay, we can write into this form. We can write into this. So this one, the first x1 here is actually omega 1, omega 0. x2 here is omega 1, x3 here is omega 2, which is actually taken from y. Okay. Boleh faham? Sebab kita nak define dia punya one-to-one correspondence untuk phi. Okay, so this phi is so that means from x kita akan dapat atau we can write as f psi x is equals to some y, which is this y is equals to this lah. So kalau kita dapat ambil x ni from diadik punya fraction, so I can write x is 0.x1, x2, x3, and so on. So the image of phi x is given by this. Kita nak samakan dia dengan sequence of omega 0, omega 1, omega 2 because this is in Bernoulli. Okay. So kita change the position, kita nak dia dalam bentuk sequence yang macam ni. Okay, so that's why you have this kind of one-to-one correspondence. Okay, now you got already the first important information about the isomorphic. Now, let's try to verify that the transformation T and S are isomorphic. So, how to verify it? You have to look at the properties of the from the definition of isomorphism. So, the first properties is show. Now, we want to show T and S are isomorphic. So now, the first properties is for any A in F1, kita akan dapat measure or the image of A is measure pula dah. The image of A is in F2. Okay, kita tengok first part dia dulu. Now, how to show it? So the first case, you can show it by letting. So I let A tu kena be any set kan. So I in a segment. So A I let it to be from 0 to 1/2. So this is interval segment. So this is interval segment. Okay, so the image of A is what? Image of the set A is given by in terms of the cylinder set. So first you have omega taken from Y. So what happens to the digit? So you will have the first digit x0 omega is equals to 0. Correct? Because the first digit is 0. Betul tak?
Betul.
Okay, first digit is 0. So let's contoh. Let's say you have this segment 0, 1, 1 kan? Segment 0 dengan 1. Okay, so you have this 1/2. So kalau between 0 and 1 ni, kalau 0 and half, so that means the first digit here, x0 here. So this is the first digit is equals to 0, this part. And the second digit actually equals to 1. Okay, so next. Okay, now another example. I do it color lain pula. Okay, color ni. So if you have A, let's say this one A1. This one becomes A2. So if you have 1/4 and 1/2, what is the image of this one A2? You can write it as in the same omega taken from I. So the x0 omega is again 0, right? What about the second digit?
Doktor, sangkut doktor.
Sangkut lagi. Sampai kat mana sangkut tu?
Okay, baru keluar.
Kena slow-slow lah. Alright, okay. Now I change. Okay, now I repeat. Now we are in the stage of showing that T and S are isomorphic. So to show that they are isomorphic, we have to consider three properties. So the first one, for any A is in the sigma algebra 1, so we have the image of A is in sigma algebra 2. So now you have to choose. A is a segment which is in the dyadic transformation, and you get the image in the Bernoulli transformation, which is this one. So in the case of interval segment of 0 and 1/2, you will have the first digit is 0, and for this part, you will have, sorry, ni saya salah explanation. For the case of this one, for the case of 0 and 1/2, sigma A1 is always 0 here. The first digit is always 0. So kalau A2 is equals to 1/4 and 1/2, so the image of the segment A2 is, so that means the first digit is 0, because if you look at this part, 0 and here 1/2 and 1. Oops, okay, so you will have here 1/4 and here 1/3/4. Apa maksud dia kat sini? Maksud dia the first digit 0, the second digit 0, okay. For this part, the first digit is 0, the second digit is 1. For the third interval segment, for the first digit is 1, the second digit is 0. And for the fourth interval segment, you will have the first digit 1 and the second digit is 1. Is that okay? Is that okay, this part? Tak faham. Tak faham. Okay, first. Okay, I repeat. Okay, for the case segment A1 between 0 and half, the image of this, that means the image of between 0 and 1 ni kita ada half kan. So since the kalau interval segment tu kita ambil point dalam ni, the first digit is 0. Dia tak ada second digit sebab dia divide by 2 saja, sekali je. Sebab the first digit can be 0 or the first digit can be 1. So the first digit is either 0, is from 0 dengan half. Kalau dia punya segment is between half dengan 1, the first digit is 1. Is that okay?
Doktor, Y kita sekarang 0 dengan 1
Y? Y kita dalam Bernoulli. 0 dengan 1. Ya, kita nak Bernoulli apa? Bernoulli kan dalam bentuk ni. Sama ada omega 0 kita nak jadikan 0 or 1. Boleh tak?
Okey,
kita guna ni ha. Nanti kita guna yang ni nanti. So just ni nak apa tu, nak specify first digit second digit berapa. Yang ni first digit second digit nanti. So for the case of interval 0 and half, you have only the first digit. Kalau A1 is this, so kalau A1 is another segment which is half to 1, okay, you had the image of this A1 in chocolate, in brown color. So you have omega is from Y, x0 omega is equals to 1. So this is how we define it in the image in the Bernoulli form, in cylinder set form. Is it okay?
Doktor,
Ya.
memang kita mula dengan kosong, lepas tu 1. Macam tu doktor?
Macam mana kita mula dengan kosong? Yes. Mesti kita kena mula dengan kosong and then 1.
Okay, doktor.
Okay, good. Okay, now if the question is in A2 ni, A2 is in the segment 1/4, 1/2. So kalau between 0 and 1, we have to consider only between 0 and 1. We divide by 4. So that means your image will be, the image of A2 is, the first digit is 0 because 1/4 is between 1/4, 1/2 is between here kan. So that means the first digit is 0. So that means the second digit is 1. Is that okay? We always start with the first digit. Boleh faham tak?
Boleh?
Okay, good.
Doktor,
Yes.
kalau kita ambil 1/2 ke 3/4 tu dia dah tak ni lah.
Dia tak ni.
Isomorphic.
Tu kita tak sure. Itu you can show it by yourself. You can try. Lepas ni kita boleh try tengok. Boleh tak 1/2 ke 3/4 boleh jadi isomorphic ke tak? I think it doesn't matter when if you choose any interval segment pun, sebab dia memang kita akan dapat balik the two transformations isomorphic. Sebab yang ni kita just ambil one of the segment untuk find the measure. Okay. Let's say if you have another A2, kalau A2 in segment 3/4 dengan 1, what is the image of this A2? So you can write as omega in Y. So the first digit is 1 and the second digit also 1. Because this one is this part here. Okay, so far we only interested with the different with the different digits. Let's say I use this one and this one. I mean at 0, the first digit 0 and the second digit is 1. Okay, what about if you have another example which is, call it as A3. So A3 is between 1/8 and 1/4. So how is the image of the A3? So first you need to you see 0, 1. Okay, now you have to divide by 8. So you have 1/4 here, 3/8, 1/2, 5/8, 3/4 and 7/8. Okay, so here for this case, you will have, kalau 8 maksudnya you have to divide by macam 2/3. Maksudnya you will have 3 digits. So the first digit is 0, second digit is 0, third digit is
0
juga in this segment. Okay, next, kalau 1/8 to 1/4, first digit is 0.
001.
001, correct. Next.
010.
011.
010.
010. Dia kena macam ni. Tak apa, buat dulu. Lepas tu nanti 0.
011.
011. And next.
100.
100.
101.
Okay.
110.
1, 1, 1.
Yeah.
Sebab apa? Okay, kita tengok. Dia punya tu macam dia punya, sebab ini kalau dia bahagi 2 jadi 0, 1 kan. So ini 0, ini 1. So all of this mesti kena 0, 0, 0, 0. And ni mesti kena 1, 1, 1, 1. The first digit. Next, kalau divide by 2 lagi, so you will have 0 kat sini, 1 kat sini, 0 kat sini, 1 kat sini. So you will have 0, 0, 1, 1. Okay, lepas tu sini kena 0, 0, 1, 1. Is that okay? 2 kali 0, 2 kali 1, 2 kali 0, 2 kali 1.
Okay.
Kalau divide lagi bagi dengan 3 dapatlah 0, 0, 1, 0, 1, 0, 1, 0, 1. Macam tu. Dia kena sentiasa macam tu. Selang-seli. So you have kat sini 0, 1, 0, 1, 0, 1, 0, 1. Okay? Clear eh? So for the case of kalau 1/8 to 1/4, this part, so you will have the first digit x1 omega. X0 is 0, x1 omega is 1, a0, and the third digit is 1. Okay, this is how you get the image from the diadic to the cylinder set. Okay, now let's try. So this case settled. Now you want to see kan, first for any A of, so for any A in F1, you will have the image of A is in F2. So all of the example shows that it is correct. So the image of the each cylinder are in the cylinder set. So that means this implies that our image lah yang kita dapat ni adalah in F2. So verified for the first properties. Okay. So again the isomorphic part, the first properties here ni kan, this one. So for any A in F1, you have to show the image of A is in F2. So actually kalau dah 1-to-1 correspondence, kalau you have another set B in F2, you can show the inverse of B is in F1. So it's enough for us to show only this part lah. So next we go to properties number 2, which is for any A in F1, the measure of A is the measure 1A is equal to measure 2 of the image of A. Okay, now let's try to go and have a calculation about how to show the second properties. Let's try this part. Okay, now number 2. So for any A in F1, I have M of A is equals to mu of phi A. Kenapa saya guna M? M kat sini untuk diadik, mu kat sini untuk Bernoulli. Mu1, mu2 kan? Okay, now A1 tadi is from 0 until 1/2. So measure of A1 berapa? Senang je.
1/2.
1/2. Sebab 1/2 minus 0. Now, find the image of A1 tadi. So the image is, the first digit is 0. Okay. So you have measure. Because here mu ni, phi ni is in the sigma algebra 2. So we have to use mu. mu of the image of A1 is equals to M of measure of the image of A1, which is equals to kalau yang ni apa? Macam ni apa dia punya measure untuk yang ni? Untuk this point. V0 kan?
V0.
Okay. So
Betul.
kalau M, so V0 is equals to 1 over 2 sebab M ni kita dah dapat tadi. Okay, now you have show that for the example. Now for the second one, A2. Second example yang tadi tu, I have 1 over 4 dengan 1 over 2. So you find MA2 is equals to 1 over 2 minus 1 over 4 is 1 over 4. And you have the image of A2 is equals to omega taken from Y, where the first digit is 0 and the second digit is 1. So this mu of A2 here, phi A2 is V0 multiply with V1, right? So V0 tadi kita guna 1 over 2, correct? 1 over 2 multiply, yes. Multiply with 1 over 2, you have 1 over 4, which is the same. So that means our second properties are satisfied. Any problem so far?
Sekejap doktor nak salin.
Nak salin, okay.
Doktor,
Ya, ya.
dan yang V0 dengan V1 tu kita dapat sebab doktor dah ni awal-awal tadi kan?
Sebab saya dah define awal tadi. Sebab nak selalunya kalau bernuli kita define by that way lah, 1 over. Kita define apa tu? Dia uniform. Dia maksud uniform maksudnya dia punya probability semua sama. Kalau 6 lah, 1 over 6, 1 over 6, 1 over 6, 1 over 6.
Yang ni sebab dia 0, 1, sebab tu kita buat 1 over 2 dengan 1 over 2.
Correct. Sebab E dia tu adalah from 0 to 1, 0, 1 je.
Okey doktor.
Okay.
Dah salin.
Okay dah, alright. Kita move on to the third properties. So for the third properties is commutativity. So that means from phi x to y, you want to show that, okay, ni kat saya ni balik. So this one commutative. So this is t, this is x, and this is phi and phi. Okay. So again, for the dyadic function, we define x is to be 0.x1, x2, x3, and so on. So the image of this phi x is what? So the image kan macam kita cancel this, the first 0 point ni, kita akan dapat x1, x2, x3, and so on. Okay, this one is in the transformation number T. Okay, now the first part ni saya lalu from here to here. We mean that from x to y here. So saya apply phi dulu. Ni. And then saya apply t. Ni from this one. From this. terbalik ni. Bukan macam ni. Okay, this apply ni dulu. Nak pergi from here to here. Okay, first X, okay dapat yang ni, phi X. Phi X. Okay, now I want to find Tx. Okay, Tx. Kalau T of X is equals to 2X mod 1 kan? So kalau X2 is this apa tu? Function. So I have 2 darab dengan X which is 0.x1, X2 until so and so on, and then mod 1. Okay, so kalau 2 darab dengan 0.x1, x2 jadi apa? So macam kita darab macam ni. Jadi kita dapat apa? 0.x1. Kalau darab 10 dapat berapa?
x1.x2.
Kita pindah kan? Kita pindah dot ni. Dapat x1.x2 and so on. So sama juga kalau darab dengan 2. Sebab kita consider diadik function. So kita darab dengan 2.0, darab 2 darab dengan 0.x1, x2 kita akan dapat
x1, x2 point
x1 point x2, x3 and so on. Betul? Okay, now kalau kita ambil mode 1 pula. So if x1 is 1, then we remove 1. Is that okay?
Doktor, kenapa 2 equal to 10 kalau diadik?
Diadik, kita sebab kita consider diadik numbers, macam bukan decimal.
So kalau 1 to 1 lah.
Kalau 1 to 1.
10.
Dia macam dia punya function. Kalau kita darab dengan diadik transformation, 2 darab dengan nombor perpuluhan tu, kita macam pindah dia punya dot tu ke kanan, macam kita darab dengan 10. Sebab apa 10? Sebab 10 tu sebab kita consider decimal kan, decimal places. Tapi yang ni kita kira in diadik punya form. So that means kita buat macam 10 juga, asas 2 macam tu.
Okay. Baru ingat.
Baru okay. Lepas tu kalau x1 ni 1, kita kena remove 1. Maksudnya kita kena tolak dengan 1. Betul? So kita akan dapat 0.x2, x3 and so on. Is that okay?
Okay.
Okay. Boleh kan? Okay, now. So that means what is your, so if you collect them together, so I have phi t of x. So phi ni tx tadi adalah 0.x2, x3, x4 and so on. So we apply the map phi, so you will have x2, x3, x4 and so on. So this is your phi tx. Is that okay? Alright, so now we move on to the, saya kena tambah page. Okay, so page 9, 10, okay. Mana tadi? Okay, now kita dah dapat dia punya phi tx. So now from the another way, So kalau untuk this part, you have to show phi tx is equals to s phi x. So this one, kalau in the third property. Mana pergi dia punya tadi? Okay. So now you have the left hand side. So now you want to show the right hand side. So for the right hand side, you have, again, you know that phi of x is what? Let's try to write. Okay, phi of x is equals to, so x is equals to 0.x1, x2, x3, and so on. So phi of x, you can have x1, x2, x3, and so on. So s of phi of x. So what is s? S is like you shift, right? You shift to the left. It's a Bernoulli shift. So that means you shift to the left. So as according to the definition of Bernoulli shift, so I have S omega n is equals to S omega n plus 1. So now you shift to the left. So I have S phi x is equals to x2, x3, x4, and so on. Is that okay?
Yes.
Okay, so that means you have shown that your function here is equals to this S of phi of x. So with these properties, these three properties satisfied, that means you have that means the transformation T and S are isomorphic. So they are the same. Okay. So the conclusion is the transformation T and S are isomorphic, and since Bernoulli shift is ergodic and mixing, then we can conclude that T and S is also ergodic and mixing. So kalau isomorphic, that means apa-apa properties for the transformation T akan dapat juga pada transformation S. Maksudnya dia copy, dia similar, dia macam kita copy apa benda yang copy paste je. Apa properties yang ada pada T akan ada juga pada S. So tu. Is that okay?
Okay.
Alright. Okay, so for tomorrow pula. For Thursday, I'll stop here. For Thursday, we will continue for another example, which is for Baker's transformation. And also we will try to discuss the, let's say we have Baker's and also the double-sided sequence, and show that they are isomorphic also. Okay. Any questions so far?
Doktor nak tanya, kalau contoh kan dalam exam, soalan dia jenis show ni ke?
Maybe akan ada contoh macam show lah. Kalau show, mungkin akan ada examples lah. Macam saya bagi example tadi, ada segment from here to there ke. To show two transformation, kalau diadik macam ni dengan properties macam ni adalah isomorphic dengan contoh Bernoulli macam ni dengan properties yang macam ni. Maybe akan ada. Macam tu lah kalau saya buat soalan lah. Saya akan buat maksudnya maybe akan ada hint lah dekat situ. Akan ada semua information that you need untuk show yang they are isomorphic. Kalau saya tak cakap apa-apa, maybe kalau saya tak cakap apa-apa, maybe tak bagi tahu contoh segmen macam ni kan. Segmen A apa, A2 apa, maybe you can decide lah nak guna berapa pun.
Okay.
Tapi lebih senang guna spesifik lah macam ni. Saya akan bagilah ni segmen ni supaya you can show. Okay. Alright, so in that case, no more questions? Okay, if no, then I see you on Thursday, insyaAllah. So thank you for your patience and also for your attention. Okay, so I end this class with Assalamualaikum warahmatullahi taala wabarakatuh.
Thank you.
Okay, thank you.
Thank you, Dr.
Welcome.